Exercise 4A, question 4. Okay, so we are asked as a show that to the series expansion of that function. So I have got 1 plus x over 1 minus 2x is my function, and I need to show that it has a series expansion of 1 plus 3x plus 6x squared plus 12x cubed. Now, as a show that, I need to make sure I show enough work. So my initial step is to turn this into a product. I need to turn it into a product because I need to do a binomial expansion on it. And to do that, I need it to be a power in an index form that I can use. Now, I don't need to do anything with this part. That's fine. 1 plus x has no power, so I don't need to do an expansion. If they were being a bit nastier in this question, we'd have to do both, but we're being a little bit nicer here. So I'm literally just going to expand on the 1 minus 2x to the minus 1, and then I can pop that back in and multiply it. So my x is minus 2x, my power is minus 1. So off we go. 1 plus nx, so that's minus 1 minus 2x, remembering that whatever is in that x box, which is minus 2, I just about caught the minus, has to go in a bracket. So there's my nx plus n minus 1 over 2 minus 2x again, importantly in a bracket because all of that will be squared, plus my n minus 1, n minus 2 again. I am working out n minus 1 and n minus 2 in my head. If you can, as you go, it does make life a little bit easier. I've got minus 2x cubed. Okay, let's neaten that up and then we'll put them back together again. So I've got 1 plus 2x. I've got 1, 2, 3, 4 minuses, so it's going to make a plus. The 2's will cancel. 4x squared. And then on the next one, I've got 6 divided by 6, which is gone. 2 cubed is 8. And I have got 6 minuses, so a plus, so 8 cubed. Okay, put them back together again. So again, I'm going to show and clearly know what I'm doing. So f of x, the function, is 1 plus x, and now I'm going to put in the 1 plus 2x to replace the 1 minus 2x to the minus 1. So again, I'm being very clear and methodical in my working. I'm getting full method from, if this was an exam question, about showing that I know the steps that I'm doing it in. So let's start with doing all the 1 multiples. You don't need to draw the lines on. I'm just trying to make it clear what I'm doing. So that's 1 plus 2x plus 4x squared plus 8x cubed. I'll do lines for the next one, although I'm going to run out of space. Then I'm going to do that one, and that one. The reason I'm not doing x times x cubed is it makes an x to the 4, which I don't need. So there's no point writing down anything that we don't need. So I've got plus x plus 2x squared plus 4x cubed. I'll notice I'm being very methodical. Don't want to lose any and make any silly errors. So I have got 3x plus 6x squared plus 12x cubed. Right, fingers crossed. Scroll back up. 1, 3, 6, 12. 1, 3, 6, 12. Check. And it is always worth checking in a show that question, because if it's an easy mistake to fix, you're fine. Now, it says, what is it valid for? So you only need to think about your binomial expansion for this part, and I only had one binomial expansion. So it is valid for 2x less than 1. The modulus of 2x is less than 1. Remember what we've said in the past videos? The minus sign does not go into the modulus. Modulus is get rid of negatives. So if I simplify that, modulus of x is less than a half. Or if you prefer in interval form, x is between minus a half and a half. Okay, so that's a nice question all finished.